Okay, this panel is now open to questions. We'd be very happy to take your questions. And again, please just be reminded, please do come to a microphone to ask your questions. So go ahead.
I'll be brief given that it's separate time. I'm Ted Mitchell from Texas Tech. I'm fascinated by the conceptually about how our community in America seems to be losing its innovative edge. And one of the things that we all agree about is that if you don't get your education in STEM fields, you lose the didactic experience that you need for the technical part of succeeding in universities. Could it also be that part of the innovation that we lose is really the problem-solving part of things? Because I don't think it's a coincidence that if you look at the Fortune 400 companies, the CEOs are loaded with engineers. So I mean, I think there's a part to STEM field education that really is not just the didactics of it, but it is the whole innovative problem solving. We see an issue, we see the issue a little bit different than somebody else might, and we look for a way to solve it. So having said that, should it be that when we're trying to address education, not again at the university level, but at the K through 12 level, should it really be that there's the emphasis on STEM field education is really the way to address a decline in innovative thinking? And if we try to catch people at the graduate level or the postgraduate level and then try to teach them how to be innovative, is that closing the barn door after the cow's out?
Yeah, well, thanks. It's a great question. My own belief is that children are innately massively innovative. I mean, anyone who's ever had a child knows that at a young age, it's all about questioning. Everything's questioned. The sky's the limit. There are no barriers. I think that what we do in K-12 education, unfortunately, is that we take the creativity out of our children. Our educational structures are very hierarchical. Science is very hierarchical. My kind of approach to this is to start with higher education and developing this training program, but clearly, ultimately, one would want to really develop this at younger and younger ages to kind of put the creativity back into education. But the other comment that you made is equally as important, which is that when you're talking about scientific innovation and teaching scientific innovation, you also have to remind the students that the technical training, developing the methods base, whether that methods base be the method of how to innovate or the method of how to solve problems in engineering, they're both equally important. You can't be a scientific innovator without kind of understanding the nuts and bolts of your science. So both are true.
Yeah, I think also if you look at that relationship, it's amazing to me, the relationship between music, whether it's classical guitar, classical piano, because music can solve a problem. Here in Austin, it's amazing to me how many of the people who are problem solving have a sort of a music background. I also think that in universities there are core disciplines, so therefore engineering is applied mathematics. So when I was in college, it was engineering, liberal arts, and journalism and accounting. So therefore, if you look at the core discipline of engineering, it might be mathematics. So I think that getting early mathematical skills becomes very, very important. And I also think those skills are transferable to other ways in terms of the creative things that happen with children. I think the worst thing is, as we are parents ourselves, is to just do what I call the trade school bit when you go to college. I think that you should learn as much as you can, everything from the mathematics to music appreciation to all those kind of things that we were forced to take because I think there's a relationship between how you think about the world and solve problems and then applying those things in a way that's analogous to problems.
The only comment that I would raise to second all of this is that our experience in the commercial world is our most successful innovators have one thing that is unquestionable. They have business knowledge that makes them functional experts about process and the ability to think through how they can change or apply the process to leverage that new idea or capability. I've seen no example of the 91 ideas that we've implemented where it has been somebody who's a novice or who has very, very light knowledge about technical issues of business competence.
I'm sorry, go ahead. Next question.
Yes, first off, comment. It's been said that children start out as engineers. You put some blocks in front of them and they'll start building something. So very early they have that skill. And then we teach it out of them. So that's a comment on the subject that was just mentioned. John, I really enjoyed your talk because I really feel like George Kosmetsky played a tremendous role in the development of Austin as a technology center. Certainly he was a big in the IC Squared Institute, the forums and symposiums that were held, played a big role in my education as an entrepreneur trying to build a company with no business background. Certainly I participated in many forums and things, and it was very, very helpful. So I was glad to see you bring up George Kosmetsky and the IC Squared Institute and the role they played here in Austin. So thank you.
Yeah, thank you. You know, as a director, of course, George forced me to do this on his deathbed. So if you know George, you understand that. But I think it's very, very true. That is, when I visit communities, whether it's in America or in other parts of the country, it's important to have someone who's a catalyst, who understands. And of course, Kosmetsky had done Teledyne, and of course, he had engaged in that whole process of technology transfer. So basically, he taught, I think, the entire region how to think about the world differently. And by the way, Bill Cunningham is finishing a book on George Kosmetsky and his contributions to the University of Texas and science and technology. So to us at UT Austin, and certainly as we move through the time, we must remember the contributions of George and how he created so much wealth and created so many opportunities, and more importantly, left a way of thinking about science and technology and the commercialization of that science. So I'm happy to represent that viewpoint.
George Lister, UT Southwestern. A comment and then a question. A comment for those of you who haven't ever heard the 16-minute video of Sir Ken Robinson. If you haven't, it absolutely amplifies what Dr. Ness talked about. He is a remarkable speaker who is one of the TED lecturers, and he talks about imagination, creativity. My question for Dr. Ness, or actually for all of you, to the extent that at the moment there's a huge focus, particularly in medical education, on derivation of content, which we may be able to test perfectly because we can turn around and create a standardized test, but test nothing about nimbleness for handling things in the future as the world changes, as the information changes. What do you think are the tools that might help educators relax a bit over the constant stuffing in of content, and instead the recognition that we may have actually swap a little bit of content for nimbleness of thought?
So the first thing to say is that obviously you are an audience plant, because I was dying to have somebody ask me that question. And the second thing to say is I have no idea how to get people to relax, but I have a very strong belief that our educational system should be really defined by content with a little c and context with a big C. Let me actually give you an example of that, a very concrete example in terms of medical education. So, you know, I am a product of a medical education. It was pretty awful. And I define it as, I remember it as being, you know, kind of taking lots and lots of information and putting it down my gullet and asking me to regurgitate it. And what I wasn't taught was how to think about that information. If there's anything that is absolutely critical in a clinical context, it is decision making. Yet, we do not teach, we classically do not teach in medical education the the tool, the paradigm, the scientific paradigm of clinical decision making. And what I mean by that is, literally kind of pre-test probability Bayesian, pre-test probability, test characteristics, post-test probability. How do you actually take this information and use it in the context of making a clinical decision? We don't teach our medical students how to do that. I would argue that that should be literally the very, sun around which kind of the content revolves. So I believe that this concept of content with a little c and context with a big C actually applies to every element of higher education, and you can take that idea and you can take it into business schools, you can take it into law school, you can take it into medical school, you can take it into engineering, architecture, and everything else. So I absolutely couldn't agree more with you, and thanks for asking the question.